We have one other type of expression, or one other way that we use continuity. And the other way that we use continuity is this. Our third and final way is, it's called extending the function. Okay? What they want to know is, you're going to look at a set of functions, or a function, and I'm going to give you this function. It'll be f of x equals x squared minus 6x plus 5 all over x minus 1. Okay, so we have this function. And what we're going to do is we want to figure out what we can do to make sure that this function is continuous. So our goal is always to make this continuous. So what do we have to do? Well, first of all, we have to find out where it is discontinuous. So think back to what I've been saying. Anytime it's discontinuous, it's places where you have a jump or a gap, or you have a vertical asymptote. Well, let's check to see what we have with this function right here. So the first thing we're going to do is, let's just do a little bit of factoring just to see what sorts of stuff we have here. So I'm going to factor this and see if we have anything that cancels out. So let's factor x and x. And now, what are the things that multiply to give me 5, but add together to give me -6? So clearly that's going to be -5 and -1. X times -1 is -1. -5 times x is -5. So this cancels out. That means that we have a hole or a gap. So when you're trying to extend a function, you are trying to figure out, what do you need to put into that space to make sure that it is continuous? So we have to think about this as a limit. But the limit is going to be at what value? Well, where is the hole existing? Where is the gap existing? Well, that gap exists at x equals 1. So we want to find the limit as x approaches 1. We want to know what that is. But we just did the math, so let's find the limit as x approaches 1 of x minus 5. Because we factored it, we've removed the problem that would give us 0 over 0, and now we have x minus 5. So do direct substitution. 1 minus 5 equals -4. Okay, so we know that if, as we come from the left, it's -4. As we come from the right, it's -4. If it's going to be continuous, the value has to equal -4. So this is how we extend a function. What we do is we basically say we have the function x squared minus 6x plus 5 over x minus 1 for all values except x cannot equal 1. Okay? So we're telling ourselves everywhere else we're going to use this function. But we're also going to say x is going to equal, at x equals 1, it will have the value of -4. So what you've now done is you've now written a function where you have filled in that one single space. So for everything that isn't 1, what we have here is at 1, we have this function that goes like this. There was this gap here, and then the function goes like this because it's an x squared function or whatever it's doing. And then what we've done is we've added that extra piece. That at x equals 1, it has to be -4. So what we've done is we filled in the gap with a value, and now it makes the function continuous all the way through. So that is what we call an extended function. So that is the stuff that you have to be able to do with continuity and algebra, okay? So it's a lot of basically thinking about it as coming in from the left, coming in from the right, and using the definition of continuity, that the left and the right have to be equal, along with the value having to be equal. So I hope this helps. We will do some more math with this in the future. Hope you have a great rest of your evening, and I will talk to you in the next recording.